Hola guys, welcome back to my channel. Today we are going to solve a very interesting probability question. So this is the question taken from the matriculation level. So let's get started. So first we need to read the question. So when Ahmad goes to work, he has to pass through two sets of traffic light P and Q. So the probability that he has to stop at P is this, okay, and the probability that he has to stop at Q, given that he has to stop at P, is this. So the probability that he does not stop at Q, given that he does not stop at P, is this value. So first we need to construct a tree diagram. So let me define the event. So let me define the event P. Let P is stop at P and Q is stop at Q. So this is the event that I define. Okay. So let's begin our tree diagram. Okay. So first we have at traffic light P. So the probability that he stop at P is how much? Is 7/20, and not stop is the complement, which is 13/20. So it's simply 1 minus 7/20, right, which is 13/20. Okay, so what about for Q? So for Q, we need to do the two branches like this and like that. So this is for the case of Q. So let's see. From the question, stop at Q, given that he stopped at P, is 7/10. So he stopped at P. Then over here, if he stops at P, then the probability is 7/10, right? So over here is 7/10, and then the complement is 3/10. Okay, so it's 1 minus 7/10. Okay, so this one is not stop at Q. So this is stop and not stop. Okay, looking back to the question, the probability that he does not have to stop at Q, given that he does not have to stop at P, is 2/5. So not stop at P, not stop at Q is 2/5. Okay, so the complement is simply 3/5. Alright. Okay, so our tree diagram is done, and then we need to find the probability that he has to stop at P and Q. Okay, he has to stop at P and Q. So P probability probability stop at P, N. So N is basically intersection, like this, intersection Q. Okay, so the probability is, so because this is conditional probability, so if you still remember Bayes' theorem, so Bayes' theorem is P, if we have a P intersection P, so the formula is P probability stop at P times probability of Q given P. Okay, so let's check our tree diagram. So probability of P is over here, stop at P is 7/20, and then probability stop at Q given he stop at P is 7/10. Okay, so it's 7/20 times 7/10. So this is simply 49/200. Okay. Alright, next question is question C. Find the probability that he has to stop at least once. Okay, at least once. So actually we have two ways to do this. First, we can find the probability that he stopped at least once, which is at least once is over here, right? So 1, 2. Okay, so that times that is the first stop. Okay, so probability stop at least once is 7/20 times 7/10 plus, okay, or he can stop at P but does not stop at Q, so that also consider as stop at least once, right? So he still stops at P, which is considered as 1 times. Okay, so it's 7/20 still times 3/10 plus, and then the last one is when he does not stop at P but he stopped at Q, so it's also consider. Okay, so what is that? 13/20 13/20 times 3/5, and then so the last branch, which is this one, is not considered, okay, because if he does not stop at P and Q, so it does not satisfy our question, right? So you don't have to include that. So when you calculate our the value of this operation, you will get, it's supposed to be 37/50. Okay, right. Or the alternative is, you can do like this. So probability stop at once is 1 minus P not stop at all. Okay, not stop. Okay, not stop at all. So not stop at all, which means this part, not stop at P and not stop at Q. So not stop at P is 13/20 times 2/5, is it? 2/5 2/5, and then you will get the same answer. Okay, alright, so continue to the next question, D. If he has to stop at Q, so given he stopped at Q, what is the probability that he would have to stop at P? Okay, so this is conditional probability. So what the question says, if he has to stop at Q, so what is the probability he has to stop at P? Which means, to be translated into the mathematical form, it is probability stop at P given he stop at Q is what? Okay, so this is the mathematical form. So the formula for this, according to Bayesian theorem, okay, so Bayes' theorem said that probability of P given Q is equivalent to probability of P intersection Q divided by probability of Q. Okay, or also equivalent to probability of P, oops, so this is equivalent to probability of P times probability of Q given P divided by probability of Q. But for this case, we need to use this first formula, okay? So P given Q is probability of P intersection Q. We have done it in the part A. So part B. So this one, okay. P probability of P intersection Q is 49 over 200. Okay, 49 over 200 divided by probability of Q. Probability of stopping at Q. So let's find it over here. Probability of Q, probability stop at Q is, stop at Q, we have two possibility. So stop at Q, which is this, then he has to stop at P, or this, stop at Q, or he does not have to stop at P. Okay, so we have two possibilities. So one possibility is this, the green path that I've been highlighted. So it's 7 over 10 times 7 over 20 plus, then the second path is over here, stop at Q but does not stop at P. Okay, 3 over 5 times 13 over 20. Is it 13, yes. Okay, so this is how much. So that's equals to 127 over 200. So we substitute into here. 127 over 200 is 49 over 127. Okay, right, we have done all four of the question A to D. Right, so I think that's all for the short video, and I hope you can understand my explanation, my writings, and also my handwritings. All right, so yeah, thank you.